Morning, Elle. Good morning, sir.
Morning.
I am glad to have you back today. And welcome to our lesson. And for those who are not able to attend, we welcome you and watch the video after for your reference as well. Okay. Elle, maybe we can have a review of what we had yesterday.
Expanding algebraic expression, ma'am.
Expanding, yes, that's right. So, do you have any homework? No?
Yes, ma'am.
Yes, okay then. Can we have first even just one?
Here's my example,
Okay
ma'am.
then.
3,
Okay.
3, parentheses,
Yeah.
6x plus 4.
May I have it again? 3 parentheses 6x plus 4.
4.
Am I right?
Yes, ma'am.
Yes. And how do we expand this expression?
3 times 6x,
Okay.
then 3 times 4.
Yes.
The final answer is 18x plus 12,
Okay,
ma'am.
let's check. 18x plus 12. Can we combine them?
No, ma'am, because, hindi sila like terms.
Yes, okay then, because 18 has the variable x, however 12 doesn't have. So 3 multiplied by 6x plus 4 is equal to 18x plus 12. Okay, good job. I think you're ready for the next. This time we will be having the chapter about polynomials, where prior knowledge needed is the lesson about integers, which I believe you already have the session with, sir. And then also the additive inverse. Additive inverse, the addition property of equality, that is where you transpose to get rid of some terms to have a value of the variable. And as well as the distributive property, which we just had yesterday, or what we call the multiplication property of equations, of equality. And then simplifying mathematical expressions. So because we already had this one, then for this chapter, you are expected to expand your knowledge of polynomials to include expressions with more than one term, such as binomials and trinomials, and then learn also to add, subtract, and multiply polynomials. So this time, let us recall about polynomials first. Okay? Any idea about polynomials?
Ang terms is 4 or more, or more than 3.
Okay. So basically, polynomials from the root word poly, which means many. Okay.
Yes,
You have mentioned about 3 or more terms, but then polynomials does not only refer to those with more than 3 terms, but even those with 1, 2 terms, and they have specific names. Okay. Recall that a monomial is a number. Monomial. Okay. 1 is a number. A
1.
variable. Okay. Recall that a monomial is a number, a variable, or a product of numbers and or variables such as 3 times 4. Or 3 times 4 gives us a product of 12, and 12 is a monomial. An algebraic expression that contains one or more monomials is called a polynomial. So one term is a monomial, and one or more monomials is called a polynomial. Now, in a polynomial, there are no terms with variables in the denominator and no terms with variables under a radical sign. Now, we are talking about what makes a polynomial. Okay, number 1, there should be no terms with variables in the denominator. So it is a fractional expression but the denominator should not be a variable. And another is an expression can only be a polynomial if no terms with variables under a radical sign. Are you familiar with the radical sign, Ella?
Yes, ma'am.
Yes,
Mm,
okay. So under the square root or the cube root or the root, okay?
mm-mm.
To summarize, an expression is a polynomial if there is no variable in the denominator and no variable under a radical sign. Okay, we will have the example later. Polynomials can be classified by the number of terms. It is contained in the expression which um, we name them binomial if we have two terms, like z squared minus 1. So z squared and then minus 1. So we have two terms, a binomial. And then polynomial with three terms is called a trinomial. Trinomial. Example is 2y cubed plus 4y squared minus y. 2y cubed, 1. Then 4y squared, that's another term. And then minus y is another term. So a total of three terms. A trinomial, a specific name for a polynomial having three terms. Okay?
Okay, ma'am.
Clear so far? Okay. Now, polynomials also can be classified by their degrees. Any idea about degrees of polynomial?
Ah, medyo, ano ma'am,
Likap
nalipad
na.
talaga.
Okay,
Mm-mm.
yeah, no problem. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant, such as 6 or 10, is 0. If we have a constant, the terms with no variables, the degree is 0. Okay? The constant 0 has no degree. For example, the monomial 4b raised to the fifth power c squared has a degree of 7. 4 has no degree. B raised to the fifth power has the exponent 5. And then c squared has the exponent 2. So since, as what we have mentioned, degree refers to the sum of the exponents of its variables, then 4b raised to the fifth power c squared has a degree of 7. 5 plus 2 is 7.
Mm-mm.
Okay, next. The degree of a polynomial is the same as that of the term with the greatest degree. For example, the polynomial 3x to the fourth power minus 2y cubed plus 4y squared minus y has a degree of 4. So for our first example, if we have 10, the degree is 0. If we have a monomial for the degree is 7. But if we have this polynomial 3x, can you follow?
Yes, ma'am.
3x to the fourth power minus 2y cubed plus 4y squared minus y has a degree of 4. Okay, let's go back to the whole polynomial. 3x to the fourth power minus 2y cubed plus 4y squared minus y. So we have the first term 3x to the fourth power. It has the degree 4. The negative 2y cubed has the degree 3. Then the 4y squared has the degree 2. And then your minus y has the degree 1. So again, if we have a polynomial, the highest degree of a term is the degree of the polynomial. So for this polynomial, the degree is 4.
4.
Okay? Any questions so far?
No, ma'am.
Let's continue. I just have here questions or examples that we can just do together. We have to classify classifying polynomials. We mean to classify whether a given expression is a polynomial or not. Example, negative 2 over x. We are going to classify if it is a polynomial or not, and then name it a monomial, a binomial, or a trinomial.
Yes, ma'am.
Sige, can you try? Negative 2 over x. Is it a polynomial?
Not.
No, yes, not a polynomial. The reason is?
Because, ma'am, a negative denominator. A variable denominator.
Yes, very good. It is not a polynomial because it has a variable in the denominator. Yeah, that's it. Number 2, x squared minus 12 is an expression which you're going to identify, determine, I mean, if it is a polynomial or not. Is it?
Yes, ma'am. Polynomial.
Yes.
Um,
And then
binomial.
classify. It is a binomial. Yeah. Okay then. Okay. This time, let's have 2 more examples. X cubed plus 3x squared plus 8. Again, x cubed plus 3x squared plus 8. Is it a polynomial?
Yes, ma'am.
Yes. And specific name?
Trinomial, ma'am.
It is a trinomial. You got it right. Okay. And I think the last example. We have a square root of x plus 5.
Not a polynomial, ma'am.
Not a polynomial. Because?
May radical sign.
Yes, it's right. Okay. Therefore, for today, we conclude that polynomial or an expression is a polynomial if we don't have terms with variables in the denominator and no terms with variables under a radical sign. Also, we classify polynomials according to terms. Recall that a monomial is a number, a variable, or a product of numbers and or variables such as 3 times 4. An algebraic expression that contains one or more monomials is called a polynomial. And then a polynomial with one term is a monomial. 2 terms are binomials, such as z squared minus 1. So we have 2 terms, z squared and then minus 1. And then A polynomial with 3 terms is called a trinomial. 2y cubed plus 4y squared minus y is a polynomial with 3 terms. Therefore, it is a trinomial. Polynomials also can be classified by their degrees. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant, such as n, is 0. The constant 0 has no degree. So the monomial 4b to the 5th power c squared has a degree of 7. The degree of a polynomial is the same as that of the term with the greatest degree. For example, the polynomial 3x to the 4th power minus 2y cubed plus 4y squared minus y has a degree of 4.